Hi, my name is Betsy Weaver. I'm a Detector Engineer here at the LIGO Hanford Observatory. And last you may have seen me on this feed was from January, where we were talking about what the upgrades were for the detector here at Hanford, as well as at our sister site Livingston. And we were knee-deep in doing a bunch of install and hardware activity for baffles and test mass replacement in chamber. However, today we have since now closed all of the chambers. We are pumping and under higher vacuum, and the install activity has really finished, and we're now rolling into a phase that we call commissioning. And so the commissioning team now is working with the new upgraded detector that has the baffles installed, the end test mass replacement, the one ITM swap test mass that had a point absorber that was causing us grief, and a variety of other planned upgrades. So I'm here with Jenne, who is one of our lead commissioners, to give you a quick update on how that commissioning is going.
I'm Dr. Jenne Driggers, and I'm on what we call the commissioning team here at the LIGO Hanford Observatory. And what we do as commissioners is really take all the different pieces of the interferometer that are provided either by different universities and institutions or by different aspects of the detector engineering group and make them work together as one whole instrument that can be super sensitive and detect gravitational waves. So what we're doing right now is trying to just bring the interferometer back online. We've been offline for several months. We've got all of these great new components. And so what we're trying to do right now is just get them all to work together in concert and achieve the best sensitivity that we can. So what we've done so far is we can bring the interferometer into alignment. We can get all of the cavities resonating. So we've got power buildup in the interferometer cavities. We've seen already that with the better test masses, we've got about 50% more light circulating in the interferometer than we did in the past. So that's really great news. That'll really boost our sensitivity at high frequencies. And the last couple of days, we've been able to start to power up. So for O2, we operated at 20 watts of laser power injected into the vacuum system. And the last couple of days, we've been able to get to 17 watts injected into the vacuum system. So we're pretty close to where we were for O2, and we look forward to going a whole lot farther in the next couple of weeks. But that's complicated because we've got things like the thermal compensation system has to be able to deal with this higher laser power. So that's actually something that's going on right now, is they're just finishing up. They've started to turn on some of the thermal compensation system components, and now we're going to try and see how those work with the higher power laser, and hopefully that'll go pretty smoothly this afternoon. I think it will. One of the other big things that we're looking forward to in the next couple of weeks is we are using quantum squeezing now, or we will be, for our third observing run. And so the squeezing team has gotten a lot of progress on generating squeezed states of laser light. And so once we've got the interferometer at good sensitivity, we'll start to inject these quantum states, squeezed quantum states, and further improve our high frequency sensitivity. So we've got a lot going on here in terms of bringing all of the pieces of the puzzle back together, and we're really looking forward to seeing what kind of good sensitivity we can get to for O3.